Hello, this is Q and I'm going to talk to you about a calculator trick. So suppose I press some numbers on my calculator and I minus the reverse of this number.
So if I put in 846, I would do that minus 648, which will give us a number 198. Now, one cool thing about this trick is that when you do 198 divided by 9, you will always get a whole number.
So if you don't believe me, pause the video and try a few numbers. You can type in a huge number and minus its reverse and you will always get a multiple of 9, as long as you don't make a mistake when minusing the reverse of that number. Yep, go back and check your mistake. Note that if you type in a number, say 848, what you will do is to do 848 minus, 848, which will give you 0, which is strictly speaking also a multiple of 9, because 0 divided by 9 is 0, which is a whole number, so it doesn't break the rule. Such numbers whose reverse is the same as the number itself all encounter this problem. They're called palindrome numbers. So for this trick to be impressive, just don't use palindrome numbers. But how does this trick work? We count in base 10. For example, 842 means 8 times 100 plus 4 times 10 plus 2 times 1. Take another example, 848, our palindrome friend. It can be written as 8 times 100, which is 10 to the power of 2, plus 4 times 10, which is 10 to the power of 1, plus 8, which is 8 times 1, and 1 is just 10 to the power of 0. So some number in the form a, b, c, d, e, f, what it means is a times 10 to the power of 5, so a followed by 5 zeros, plus b times 10 to the power of 4, plus c times 10 to the power of 3, and so on. Now, when you minus the reverse of this number, a, b, c, d, e, f, what you're doing is a, b, c, d, e, f minus f, e, d, c, b, a. The number f, e, d, c, b, a has the value f times 10 to the power of 5, plus e times 10 to the power of 4, plus d times 10 to the power of 3, and so on. So when you minus the value of a, b, c, d, e, f by the value of f, e, d, c, b, a, you are doing this subtraction. We will go through this term by term. A times 10 to the power of 5 minus a gives us 9999 times a. B times 10 to the power of 4 minus b times 10 gives us 9990 times b. C times 10 to the power of 3 minus c times 10 to the power of 2 gives us 900 times c. D times 10 to the power of 2 minus d times 10 to the power of 3 gives us minus 900 times d. E times 10 to the power of 1 minus e times 10 to the power of 4 gives us minus 9990 times e. And finally, f minus f times 10 to the power of 5 gives us minus 999 times f. All of the coefficients are multiples of 9, so we can factorize 9 out of our expression, which is the difference between the number and its reverse, so we can get this expression. This expression is a multiple of 9, as it can be written in a form 9 times a whole number, that whole number being this portion here. Remember, a, b, c, d, e, f are all whole numbers, so this portion is guaranteed to give us a whole number. So we can see how the difference between one number and its reverse always gives us a multiple of 9. We're not done yet. I just kind of showed you that 10 to the power of 5 minus 1 is 99,999, which is a multiple of 9. But how can I be sure that 10 trillion minus 10 billion is a multiple of 9 as well? To make my proof complete, I need to prove that 10 to the power of whatever minus 10 to the power of whatever will give me a multiple of 9. So continue watching this video for the proof. So we will be trying to prove that 10 to the power of a minus 10 to the power of b is 9t, where t is a whole number. That means that we need to do the subtraction 10 to the power of a, which is 1 followed by a zeros, minus 10 to the power of b, 1 followed by b zeros. So there will be b number of zeros minus b zeros, which will give us, b zeros. Now, we need to do a minus b zeros minus a. So if a minus b equals 5, we would need to calculate 100,000 minus 1. This will give us a minus b number of 9s. So the result of this subtraction gives us a bunch of 9s followed by a bunch of zeros. And this number can be factorized into 9 times a bunch of 1s and a bunch of 0s. So the result of this subtraction gives us a whole number of the form 9t, with t being this portion here, which shows that subtracting powers of 10 will give you a multiple of 9, no matter what powers a and b are. But this only works for a greater than b, right? Because if there are a minus b 9s, you can't have a negative number of 9s, can you? So if a was 3 and b was 4, how can you have minus 1 9s? Well, 10 to the power of a minus 10 to the power of b is the same thing as minus 10 to the power of b minus 10 to the power of a. Like 5 minus 3, 2, is the same thing as the minus value of 3 minus 5, which is minus 2, which is 2. So should a be less than b, we just conveniently transform 10 to the power of a minus 10 to the power of b into minus 10 to the power of b minus 10 to the power of a. So 10 to the power of b minus 10 to the power of a will give us a positive whole number, which will be divisible by 9. So if 10 to the power of a minus 10 to the power of b is 9t, then 10 to the power of b minus 10 to the power of a is minus 9t. Take an example. 10 to the power of 3 minus 10 to the power of 5 is minus 99,000, while 10 to the power of 5 minus 10 to the power of 3 is 99,000. To sum up, when you take the difference between a number and its reverse, the result is always a multiple of 9. We explored how this trick works by considering the general case a, b, c, d, e, f minus f, e, d, c, b, a. Then we went further by showing that 10 to the power of a minus 10 to the power of b will always give us a multiple of 9. So here you go, one calculator trick and a bit of maths to prove it.